right. So today we are going to be covering upgrades in canisters. I'll explain what the upgrades are in the intercanister calls. You might find that interesting in some of the homeworks you are going to do next. And also really important stuff to really know in building your canisters. So let me share my screen. All right. Just a minute. Okay. So if you were with us in the last session, we created a canister for storing users information. Let me share with you that desktop 10. I created this in our last session. And that's where we are going to continue from. So those who were not present and we haven't watched the recording for this session, this is what we have. We have a canister that we're using to store users, right? So we have the user object, the user type, custom type. They have the name, age, email, and access level. The access level is a variant of admin, user, or guest, right? And we have the add user function. We have the get user. We have the update user, and delete, get all users, get access level, control. So these are the functions we have here. All right. So today we're going to introduce a new concept of canister upgrades, because as you know, on the internet computer, canisters store your data. They persist your data, and it won't be lost, just like a database, right? But there is a way of actually doing that. You have to know how to do that correctly, so that you won't lose your canister information as you continue to develop and working on your canister. Just like how you wouldn't want to lose your information from a database as you continue to like add more tables to your Django or application or whatever. So a few things to know. So canister upgrades, right? So there are these memory type terms you need to know. We have the stable memory, right? So this refers to the internet computer long-term data storage feature called stable memory, and it's not language specific, which means all canisters have access to the stable memory, right? A canister built with the ACE or CDK, the hybrid CDK, with Rust, or with Motoko, right? They all have access to this stable memory, and it's 400 gig at the moment. So yeah, that's the stable memory. And then we have the heap memory. So this refers to the regular WASA memory data store for each canister. So this is the heap memory. It runs in your canister, but when you upgrade your canister, this memory is wiped. It's only 4 gig. It's temporary memory. So if your data is stored here in the heap, you can use your application storing data into here, but when you upgrade your canister, this will be wiped. So you have to know about that. And then there is stable storage. So stable storage is a Motoko specific term that is used to persist data across canister upgrades, right? So when you are upgrading your canister, your data in your variables will be temporarily stored in the stable memory. And then stable variables, and then we have stable variables. Stable variables, they are the type of variables that stores data in the stable memory by default on the internet computer, and you use the stable keyword on the variables on those variables when you're persisting your data. So we'll get into the code so you can really understand all this and what's really going on. So let's start with a small example. So let me highlight this for now. We may not need it. So let's say we have our counter, right? And we have our value, let's say counter supposed to sell. Then we're just going to increase the number, right? Yeah, this code suggestion is okay, except for this part. Right. Yeah, this is really not how I would want to write my code. So anyway, so like do it like this. Okay, so we just have this variable, right? Let's deploy this canister. EFX deploy. And then let's see, we're increasing, right? You see, we're increasing to, okay, let's put another function to see. If, okay, let's save this function, let's deploy again. So we can see what we are doing. Right, to refresh, right? We get counter. Okay. Oh, that's interesting. Okay, so did you notice what actually happened here? We were counting, right? I was like already on 3. but I put new code, I deployed, and we started at 0, you see. So the code is gone. So that's what we are trying to avoid, right? We want what we have stored in our canister to remain there, to be saved, right, in the lifetime of our canister, unless we want to delete it ourselves, right? So to do that with the stable variable now, with the stable variable, you will just come here and put the keyword stable. And if you do this, the variable is now being persisted across canister upgrades. So let's deploy. Right. Let's see. Right. We're starting at 0. Let's increase our counter to 3. Right. Then let's make a few changes to our code so that it upgrades. Maybe let's just uncomment this. And let's deploy again so that there's an actual change. Cool. Right, let's refresh. Let's get counter. You see, we are now at 3. Then now our data has been persisted in the canister. It won't be lost unless we want it to, unless we have a function like reset or whatever. So you have to actually set this. It doesn't come by default, right? So you can do this on a simple variable like this. So there are data structures that you can use. You can't use this table on everything, right? There are some data structures that you can use the stable keyword on. So let's say an array you can use. You can use this table on an array of some sort. Users, let's say, what would be users? Yeah. If you have something like this, okay. We are having it before definition. I just need to put this below user, but anyway, it's not an issue. It's not our main, but I'm saying we have variables, we have lists, we have arrays. I mean, we have arrays, we have lists. Those are stable. You can actually on a list, if you have like a list of something you are doing here, you can actually use the keyword stable, and your canisters will just, and your data will just be stored in the stable storage, right? But there are some other data structures, mostly class-based data structures, right? Like buffer, trimap, hashmap, those kind of data structures. You can't use the keyword stable on them. It won't work. It will actually give you an error. Let's say stable yeah, as a non-stable type. Variable users is declared, but is declared as stable, but is a non-stable type trimap. So this trimap is not stable. And so for trimap, for hashmap, for buffer, and a few other structures, stable won't work. So what do you do now when you want to persist your state that is stored in these non-stable structures, which we said are really good structures. The internet computer now, the canisters pose functions called pre-upgrade and post-upgrade functions. So pre-upgrade and post-upgrade functions are really important. They are the ones you use for persisting your data into the stable storage. When you upgrade, your data will be serialized to the stable storage, and then after the upgrade, it will be restored back to your variable, right? So that's how it works at the moment. And you just put the functions in place, they will do that automatically. You don't have to stress about that. So yeah, and but that's how it's currently working. But there's a work being done, and I'm sure this year there's work being done on the CDK. I'm sure this year that will change. Like you no longer need you no longer need to implement pre-upgrade and post-upgrade functions to persist your data. It's actually in the roadmap. So maybe, I don't know, at the end of this year or even sooner. But for now, you have to use pre-upgrade and post-upgrade functions to have your data persisted in the canister during upgrades. So to use the pre-upgrades and post-upgrade functions, what you have to do first is to have a stable array for your data. So like I said, trimap are not stable, right? But arrays are stable. So what you have to do is to create a stable variable for users. So we can have stable, maybe we can say users entries, and it will be, we have key value pair text user, right? So we declared our stable user entries. So this variable now, during upgrade, our user data will be put into this stable variable. Then after the upgrades, it will be taken from here back to the stable variable, back to the trimap. You won't see this. It happens literally seconds when you are running like FX deploy to upgrade your canister code, right? So to create the pre-upgrade and post-upgrade, you use a system pre-upgrade pre-up system file pre-upgrade, and yeah, that's on point, except for this part. Oh, so you see what happened here? We took the iterator, and then we changed, we converted the user map to an array, iterator to array, and then we assigned them to the user entries, right? That's before the upgrade. And then system post upgrade. Then in the post upgrade now, what we need to do is to just users. Okay, this is from try map from entries. Try map from entries. Text user. Then we have user entry dot files here. Let's see. Okay. So what's wrong here? We have let here. Cool. So yeah, that's it. That's basically the cycle. So if you create other maps, you just have to do this to create an entry variable, a stable variable, and then you assign these functions. So with this now, you can rest assured that our data is being persisted across Canister Upgrades. Then we can try this out. Let's deploy. Okay, we have a nice clear. Where are you from? We are from here. Yes. Yes. Okay. So now if we add a user, so you can, so if you have values that can be selected, that need like to be manually selected, you can select them, and then you can, if you call random, it can randomly generate some values for other values and create. You see, if you want to test real quick, this is what you need to do. Right. I'm adding users, and let's get all users. Yep. Yep, our users. Yep, our 3 users. Okay, let's make a few changes and deploy again. And see if we still have our users in our canister. Refresh. Let's just go to get all users. And here they are. So pre-upgrade and post-upgrade functions have already done their magic, just as we were running TFX deploy. TFX did that for us. So yeah, that's it with pre-upgrade and post-upgrade functions, and persisting your data across upgrades so that you won't lose it. So yeah, this is really how to go about it, using the base library. But of course, some community members find this like not as a not really appealing to them, and there are some libraries that have been created, like that have been created by some developers, and like there's a stable hash map, there's a stable hash map, which means There's a step function that works like this, but you won't need to use pre-output and post-output functions. You can just use stable, and it will persist just like it's an array or a list. So yeah, there's that, but this is the normal way, simple way, and which actually works. And myself is the one I actually use. It's like it's less complicated trying to use the other libraries from other people. Some may have bugs, etc. Myself, I just want to use the best libraries, but of course there are a number of other libraries that will make some of these cycles way easier and even faster sometimes. But yeah, that's it. So now let's move on to intercanister cores. So if you remember in the previous lectures, we related that like when you are declaring your functions, right? If you put the keyword shared, this means these functions will be available to be called from other actors, right? So what we are going to do now is to do what is called intercanister calling. So as you can imagine, as you start to build some complex project, right, you won't have everything in your one single canister. You will need to call some other canisters, some canister from another service. Yourself may have a number of canisters doing different services, or calling the internet computer, some of the internet computer canisters like the ledger canister, the archive canister, some tokens canister, whatever. So you really need to be able to have the ability to do some intercanister calling. So basically what you need for internet to be able to call an internet another canister from your canister is to just to have the interface for that canister. Interface will simply mean access to these functions, something like this, like this is the interface of this canister. You just need to have access to this, and then the canister ID itself. Then there's just a way you set it up. I will show you just now. So let's deploy this to the playground. Let's deploy playground. Okay. And by the way, I'm deploying to the playground for a specific reason, just to show you something else, but you can actually do intercanister calling locally as well, totally locally. You can just deploy your other canister here and then deploy the other one. Then you just do whatever you do, and then they can start calling each other. But yeah, there's something else I will need to show you. That's why I deployed to the playground. So let's create another canister that will be calling this canister of ours. Let's do this. Let's create a new canister. And by the way, 2 days ago, the CTK was updated and improved. Really cool. So if you remember when we started our versions, if you do dfx new, you just create a Motoko CDK, a Motoko project by default. But now if you do dfx new, then you give the name of the canister. Let's just call it Intercore. Now you can now select Rust, TypeScript, Python. So really cool. Just 2 days ago. So we are going to go with the Motoko. Then we are going. Yeah, so you can choose again the front end you want. You vanilla, I'll go with no front end canister. So really cool. And then see, I'll cd into intercore. Now do code. So by the way, if you want to now have this feature of doing this, you need to upgrade to version 0.17 TFX 0.17, where you have access to like selecting the front end you want and the type of project you want to create. 17 and below, you won't be able to do this. So anyway, let's do code. Yes. So we want to be able to get. We want to call our users canister from here, from this canister here. So to be able to do that, first of all, you need to declare the interface for the canister. So you can just go with it like for the users, let's just say users canister. Let's just go with users canister. Okay. Then you say equals vector, and then here you pass in the canister ID. Pass in the canister ID, ID of the canister you want to call. And then here you just do this vector, and then you pass in the interface. So here now is where you pass in the interface for the canister you want to call, the functions you want to call, right? So you may know the canister you want to call, you may have the canister ID, but sometimes like you don't know exactly the functions the canister is exposing, because if you put the functions here wrongly, it won't work. So normally the best way, if you have the canister ID, you can just grab the canister ID that you want. Like let's say for this one, copy the canister ID, and then go to the dashboard. Internet computer, internet computer dashboard, right? And then I can paste the canister ID here. The search, yeah. So as you can see, like as you say, when you deploy your canister on playground, it's actually on the live network, right? But it's only temporary for only 20 minutes. So you can actually do everything you can do with an actual live canister, like what we did here to actually search for its interface, right? So you come to the interface. You see, these are our functions. So what you are really concerned about here is this. So we don't want the candid interface. So this is the canister interface, right? We don't want the candid interface. We want the Motoko interface. So if you're doing with Rust, JavaScript, TypeScript, whatever, you go accordingly, right, and get the stuff you want. So we want Motoko, we want this interface. Then we just come here, and then we copy the functions for the canister, and then we come in our project to test them here. All right. So really, you don't necessarily need to have all the functions of the canister you want to call. You usually just need to have the actual functions you want to call. You can, even if it's one, you can just have one function. So in our case, we are just going to need the get all users function. That's the one we want to do the intercanister call with, right? So yeah, we just need to copy the types. You can see the types. Here you can see the types for the canister. Let's just copy them. You can come and then you can paste them. Yeah. And then what you just need now is the actual canister ID. Then you just put it here. Okay. So now we have the interface. So what do we want? We want this canister to call let the users in this canister, in our user canister. So let's do this. Let's create this function. Let's call it public function. The shared function. And then another thing now, when you are calling another canister, even if it's a query function, you no longer need if you declare it as a query, it won't work. It just now needs to be a function a call that you need to go through consensus. So intercanister calling is slower. It's the same as an update call, right? So even if it's but there's another way of doing this faster with what are called composite functions, but we can deal with that some other time. But for now, if you just want to do simple canister calling, you no longer need to use the query function, even if it's a query function. You need to execute it as an update function. So let's just say get users. And yeah, that's a good suggestion. Okay, this is wrong. Right. Now you see, you don't have to trust these copilots and GPT. You have to really know what you are doing. You poison. So yeah, that's it. We have, yeah. So let's deploy it. Let's deploy this. So we have our canister on live network. So to be able to call it, our hours have to be live as well. So let's deploy it on the background. So EFX deploy background. Right. So let's open it. So now let's try to get some users. At first we get nothing. Why? Because we haven't added any users in our users canister that we deployed. So let's try that. Let's add some users to our users canister. Is here. Yeah, so you can do this. You can also call your canister from the dashboard as well, right? You can do it here with your URL, or you can do it from the dashboard. Like here, you can just come here and call what add user. It will be good. I'll just use this one though. I see things clearer more here. So we added user 1, 2, right? And now let's call get users from our Intercanister core here. And we have this record. Somehow it's not right. There is a result, but we added 2 users. Let's see. Okay, let's call it. Yeah. Now we have the new user. Let's get another one. Yeah, it had saved with the same ID. That's why it returned one record was the same ID of blank. Because once you have the same ID, it will just override the previous value. That's why we had one record. Now we have Enoch here. Let's call it again. Oh yeah, you can see. Yeah, so that's Intercanister calling for you there. Is it okay? Okay. Anyway, that's it, guys. If you have questions about this, feel free to shoot. Hope you understood. Okay, that's cool then. So that's all right. Thank you, Mr. Confidence. You have anything to share, or we can just meet tomorrow to call it a day?
Yeah, if we don't have any questions, we can call it a day. We'll meet
Okay.
up tomorrow, guys.
Okay, good. Have a good night, guys. Let's catch up tomorrow.
Cheers.